Okay, I'm sorry. The video cut off while I was teaching in the middle of the lesson. Anyway, so the title, you're going to write the title of the story that we're reading today, which is The Story of Snow, The Science of Winter's Wonder. All right, let's go and get started.
The Story of Snow, The Science of Winter's Wonder, by Mark Cassino with John Nelson, Ph.D. Illustrations by Nora Aoyagi. Our story starts on a winter day, high up in the sky, in a cloud that is very, very cold. This is the story of snow. Clouds are mostly made of air, which we can't see. Then there is water vapor, water in the form of a gas, which we also can't see. We do see the billions of tiny droplets of liquid water and ice crystals that float in the cloud. They reflect light, making the cloud visible. Snow begins.
What's a word in this little paragraph that we don't really know what it means? What's a word we can use? Leah? Visible. Very good. Making the cloud visible. They reflect light. When something reflects light on something, does it make it easier to see or harder to see? Easier to see. So visible might mean something that is easier to see. That's a good one. Good job. So the word we're going to use, our first word we're going to use is visible. So we're going to write visible here. And the context clues, it says they reflect light, making it the cloud visible to see. So they reflect light. And when something reflects light, it makes it easier to see. So they reflect light. Light. And what does it mean? What does visible mean? Good. Easier. Yeah, I guess instead of making, I'll just say easier to see. Something that's easier to see. All right, moving on.
With a speck. Clouds are mostly made of air and water, but there are also bits of other things, like tiny particles of dirt, ash, and salt. Even living bacteria can float in the wind and end up in a cloud. A snow crystal needs one of these specks to start growing.
All right, what's another word we can use? Tiny what? It says what? Particles. Particles. So the new word is particles, and the clue it says tiny particles. Tiny is the key word. And what are particles? What did we say particles are? You guys want to go? Let's go back. What is particles? Remember that was one of the tiny pieces of something are particles. Tiny pieces of something. These are particles of the snow. So tiny pieces of something. Tiny pieces of something. Okay, let's keep going.
These specks are all much smaller than the eye can see. But if you could see them, ash or soot from a volcano or fire, grain of pollen from a flower, salt left over from ocean water that evaporates, particle of soil, bacteria from plant leaves.
From plant leaves. So these are all, this is actually a text feature because it shows us like little bubbles and it has pictures and it tells us what's in the picture. This is a text feature. And it tells us, it basically gives us a better idea of what particles are. So ash or soot from a volcano, those small tiny pieces that come out of the volcano, make it look big and foggy and black, those are the small particles. The pollen off the flower, that's a small particle. The small salt that makes the ocean salty is they're particles. Particles of soil. Bacteria are particles. So these are examples of what a particle is. Awesome, let's keep going.
If the speck becomes the center of a snow crystal. When a speck gets cold enough, water vapor will stick to it. If you had a microscope that could see such small things, here is what you would see. Water vapor sticks to the cold speck, making the speck wet. More water vapor sticks to the wet speck, forming a water droplet. The droplet freezes into a ball of ice. More water vapor sticks to the ball of ice, and it grows into a hexagon-shaped ice crystal. Water vapor continues to stick to the crystal. Faster growth on the corners causes 6 branches to sprout.
Which causes it to look like what is that? A snowflake. It's a snowflake, guys.
The branches keep growing, sprouting little arms of their own. And a beautiful snow crystal is born. These photographs of real snow crystals are shown much larger than their actual size. The crystals were collected during many different snowfalls. Actual size.
The actual size is that little speck, but if they zoom in on it, look how beautiful those snow crystals are. All right, snowflakes, snow crystals, same thing. Yes, Leia. Yeah, that's how they look in real life if you look at them under a telescope. They can be different sizes, different shapes. See how these are all different? They're all beautiful though, right? All right, it is pretty. Yes? Okay, let's keep going.
A snow crystal forms as it falls. As the snow crystal gets bigger and heavier, it starts to fall to earth. It keeps growing as it falls through its cloud, taking on its own special shape. The shape depends on how wet the cloud is and how cold it is. A snow crystal can start to grow one way, but then grow another way when it passes through a wetter or colder part of its cloud. The crystal stops growing soon after falling below the clouds. Snow crystals can be stars. One common snow crystal shape is the star. Star-shaped snow crystals usually have 6 arms reaching out from a center point. The center point is the home of the speck that started the crystal. The 6 arms look alike, but they are almost never exactly alike.
Very cool. They stop growing after they fall from the sky.
Star-shaped snow crystals are called dendrites, which means tree-like. They form when a cloud is full of moisture and when the temperature hovers around 5 degrees Fahrenheit, negative 15 degrees Celsius. This is the simplest kind of plate crystal, a hexagon. Plates form when there's not enough moisture in the cloud for stars to form, and when the temperature conditions are a few degrees warmer or colder than the temperature range that stars require.
Cool, so it's like a hexagon. That's really cool, I didn't know that.
Snow crystals can be plates. Plate crystals are thin like star crystals, but they don't have arms. The simplest kind of plate is a hexagon with 6 straight sides. More complicated plates have points where arms almost grew. Simple plate crystals are much smaller than stars. They can be as wide as 1 millimeter, but they're usually a lot smaller. Actual size. The points on
Look how small that is. It's like a little speck. Cool.
this plate crystal are the beginnings of arms that were just starting to develop when the crystal fell out of its cloud and stopped growing. Snow crystals can also be columns. Column-shaped snow crystals are shaped like pencils. They're not flat like stars and plates. Columns can form high in the clouds and at very cold temperatures. They are very tiny, and when they fall, they make for very slippery snow. Actual size. Column crystals are very tiny, usually no longer than half a millimeter. A column has 6 sides. These are the 3 types. Solid column. These are the smallest type of column. Hollow column. These are longer and more common than solid columns. Capped column. The caps on each end of these columns can be plate crystals
Or star crystals. Really cool. Wow.
Capped columns like this one develop when a column crystal moves into a part of its cloud where the temperature is right for plates or stars to grow at the ends. The 2 end caps can grow to different sizes, as you can see here. If you think of a star crystal as a clock, the arms of the star crystal can point to 2, 4, 6, 8, 10, and 12 o'clock. Only those times. 6 is the magic number for snow crystals. This is because of the nature of water. Water molecules, the smallest units of water, attach themselves into groups of 6, which usually leads to crystals with 6 arms or 6 sides. A perfect star or plate snow crystal has 6-fold symmetry. That means if you divided the crystal into 6 pi wedges, each pi wedge would have the same shape.
Symmetry. That's another good word. What is symmetry? It says if you divide the crystal into 6 pi pieces, each pi wedge would have the same shape. So symmetry is when 2 things are symmetric. That means if you fold them, they are the same size and same shape. This is symmetric. They're the same size, same shape. This is not symmetric because if you look at the back, it's not the same size or the same shape. So these crystals are symmetric because if you fold them this way, or that way, they are the same size and same shape. They're symmetric. Got it?
Water molecules attach to each other in 6-sided rings, like 6 kids holding hands. When many of these hexagonal rings are joined together, a larger hexagonal crystal is formed. Snow crystals are rarely perfect. So much can happen during a snow crystal's fall to Earth, it is rare that one will turn out perfectly. If a droplet of water passes close to one arm of a snow crystal, that arm can start to grow faster. Before long, that one arm will be a lot longer than the others.
Like here, see how this one's a lot longer?
A snow crystal can be a twin. A snow crystal can have 12 arms. This is a twin crystal, which happens when 2 crystals start from the original speck and form on top of each other. A snow crystal can have bumps. If there are enough water droplets near the crystal, some can strike the crystal and freeze on contact. This gives the crystal little bumps called rime.
That is a good word. Let's use it. Rime. R-I-M-E. And it gives us clues because it says, next to it, it says bumps. And what is rime? Rime is bumps on snow crystals, right?
A snow crystal can have 12 arms. This is a twin crystal, which happens when 2 crystals start from the original speck and form on top of each other. A snow crystal can have bumps. If there are enough water droplets near the crystal, some can strike the crystal and freeze on contact. This gives the crystal little bumps called rime.
And what is rime? Rime is bumps on snow crystals, right? All right, you ready?
Many snow crystals make one snowflake. Often, snow crystals bump into each other and get stuck together. When this happens, snowflakes form. Hundreds or even thousands of snow crystals can be found in a single snowflake. Two snow crystals stuck together. Snowflakes we see falling from the sky are usually clumps of snow crystals like these. Individual crystals, which are sometimes also called snowflakes, can fall on their own, but they are much smaller and harder to see. Once a snow crystal lands, it starts to wither away. Snow crystals can't keep growing after they fall from the clouds, and when a crystal stops growing, it immediately starts to wither. Soon, the arms of the crystal break down and the crystal's shape becomes rounded. This means that if you want to see a snow crystal, you need to catch it in the air or find it very soon after it lands. When they're not in the clouds, surrounded by the water vapor they need to grow, snow crystals quickly start to erode. Try catching one on your sleeve or glove to see the crystal structure at its best.
Erode. What does that mean? What do you guys think it means? If it's not cold enough, what happens to them? They melt. They go away. They erode.
Are no two snow crystals alike? Some simple plate crystals may appear exactly alike, as seen through a high-quality microscope. When it comes to more complicated snow crystals, though, odds are that no two are exactly alike. But then, no two leaves, flowers, or people are exactly alike either. Snow crystals are like us. We're each different, but we have a lot in common. How to catch your own snow crystals. Get ready. Get these things ready so you have them the next time it snows. A piece of dark cardboard or foam core board. It should be about the size of this book. Make sure that the cardboard is stiff enough to stay flat when you hold it by one edge. A magnifying glass so you can see the snow crystals better. Now, wait until it snows. During a snowfall. 1. Put the cardboard or foam core outside for at least 10 minutes before catching snow. It needs to be cold, or else the snow will melt right after landing. Make sure the board stays cold and dry. 2. Gripping the board by one edge, hold the board out flat and watch as the snow lands on it. If it is snowing hard, step under a porch roof or some other shelter so less snow falls on the board. Otherwise, the board will fill up with snow. 3. Look at the smaller bits of snow that land on the board. This is where you will find the individual snow crystals. Use the magnifying glass to look at them closely. 4. Once you have looked at the snow, shake off the board and try again. In the right kind of snowstorm, you should be able to see many individual snow crystals. Snow catching tips. Make sure it's cold enough. If the snow melts when it hits the board, or if rain is mixed with the snow, the temperature is probably too warm. Look for tiny snow crystals, not big snowflakes. Remember, snowflakes are lots of snow crystals clumped together. Sometimes the snow is all broken up and looks like a light powder. Not every snowfall has unbroken snow crystals. If the snow just isn't right, don't give up. Try again another snowy day. Or wait until you go on a ski trip. A snow crystal is a letter from the sky. Ukichiro Nakaya, Japanese scientist, 1900 to 1962.
What does it mean when they have parentheses and it says 1900, 1962? Yes? Good. That's when he was born, this Japanese scientist, when he was born in the year he died. Very good. Very good. That was a very interesting, informative story. Okay, so that's all we're going to do today. We're just going to read the story and fill out this reading graphic organizer. All right, if you have any questions, let me know. I'll see you later. Bye.